Welcome back to Math 107 College Algebra. In this video, we're going to take a look at some of the different algebraic operations we can do on functions. So the most basic are the four functions you're familiar with from arithmetic. F plus g of x, f minus g of x, f multiplied by g of x, and f divided by g of x. And each of these operations is defined just like you'd expect. F plus g is going to be f of x plus g of x. F minus g, as you'd expect, f of x minus g of x. F times g will be f of x. I'm going to actually put the dot in here. F of x multiplied by g of x. And f of x, or f divided by g of x is f of x divided by g of x. Now, the domain of all of these functions is going to be the intersection of the domain of f and the domain of g. So, that's true for all of these three. And this intersection simply means it has to be in both the domain of f and the domain of g. Makes sense, we can't add a number that's not defined to another number. So we need to have both of the numbers defined in order to do addition. Thus, in order to add functions or multiply or whatever, they both have to be defined. The same is going to be true for division. So the domain won't be any larger than the intersection of the two domains. But there's another caveat that we have to throw in here. That's the fact that we can't divide by 0. So I'll put an and. G of x does not equal 0. So for division, it's got to be in the domain of both f and g. And we can't have g of x be 0. So, as an example, we'll let f of x be 1 over x minus 2, and g of x equal square root of x. So now, I can write f plus g of x. We simply add the functions together. And the domain on this, so f of x, the only thing that's going to give us problems is if that denominator is 0. X minus 2 would be 0 when x is 2, so there x can't equal 2. For the square root of x, if we have a negative number, we have a problem. So our domain here is going to be from 0 to 2. We can include the 0 because The square root of 0 is just 0. That's not a problem. And then everything from 2 to infinity. Now, if I ask you for f divided by g of x, so now we have 1 over x minus 2 divided by square root of x, which I can simplify into 1 over x minus 2 times the square root of x. And now the domain, out of room there, so I'll slide down so I can put it here, is not going to include the 0 because we can't divide by 0. So anything from 0 to 2 and 2 to infinity. Now in both of these cases that I've shown here, it just so happens that the function I used here doesn't have any issues with this problem, but you cannot use functional arithmetic, or what we're going to talk about next in this video, to define something that wasn't defined to begin with. So my favorite example is if f of x is 1 over x, and g of x equals x squared. If I took fg of x, that will equal x, but x cannot equal 0, because if that's the case, f of x isn't defined. There's one more idea that we're going to talk about with functional arithmetic. Actually, this isn't functional arithmetic at all, but it's still algebra of functions. That is, I'm going to join two functions with an open circle. So the definition of this is we're going to take the value of g of x and insert it into f. So, as an example, if I let f of x equal x squared and g of x equal x minus 3, and I wanted to find f of g of x, so that's going to be, actually writing it, f of g of x. So that'll be f of x minus 3. Then by definition, f of x minus 3 is x minus 3 squared, and I am perfectly fine with you leaving it like that. And I believe Webasine will be too. So, that's how we compose functions. And sometimes in higher level mathematics, we need to decompose a function. So, like if I gave you the function, the fourth root of x plus 9, and we want to decompose that. So what I always like to think of doing on a problem like this is the first thing I think of is what are we doing last under order of operations. In this case, we're taking the fourth root of something. So whatever I'm doing last, I'm going to let be my f of x. So my f of x is that I'm taking the fourth root. And then g of x is going to be what goes into that. So what I'm putting in is x plus 9. That can be helpful when you move on to take courses like calculus that you need to be able to decompose a function to make working with it a little bit easier. So that'll do it for this video. We'll discuss these ideas a little further in class on Tuesday. I will see you then.